Good morning all. Welcome back to next lecture. In the last lecture, we already said that a system of linear equation consists of two or more linear equation comprising two or more variables, such that all equations in the system are considered simultaneously. So now, in order to find out the unique solution to the system of linear equation, we must find numerical value for each variable in the system that will satisfy all the equations in the system at the same time. That is the main point here. So some linear system may not have the solution and other may have some infinite solutions. And a linear system must have at least many equations as variable to have a unique solution. So even so, this does not guarantee any unique solution. So today we will discuss how to solve the system of linear equation in two variables by using different methods. See, the system of linear equation with two variables. See, a set of linear equation in which there are two equations and two unknown variable is called, a simultaneous equation with two variable case. So there are two equations and two unknown variables will be there. And solution of such a system of equation is nothing but it is an ordered pair that satisfy both equations at the same time. So the standard form of linear system of two equation with two variable can be written as, it is ax plus by is equal to p, cx plus dy is equal to q. So here a, b, c and d are the coefficients of, x and y, p and q are the constants, and x and y are the variable here. So we have a two equation with the two unknown variables. Let us consider one example. See, 4x plus 3y is equal to 11, 2x plus y is equal to 5. So in this given example, we can say that we have a two equation with two unknown variables are there. So unknown variables are here x and y. Now, we have a different methods to solve the system of linear equation with two variable case. See, we have a substitution method, elimination method and graphing methods. Besides that, many more other methods are there. See, the substitution method and the elimination method are the most common techniques that are used to solve the system of linear equation with two variable case. And both method, involves manipulating the equation to eliminate one variable. So making it easier to solve for other variable. So here we are going to discuss the graphing method also to solve how to solve the linear equation in two variable case. So along with the substitution method and elimination method, we will discuss the graphical method as well. Now first one we are going to consider the elimination method. See, in the case of elimination method, we have a two given linear equations are reduced to one linear equation with unknowns by eliminating one of the unknown variable and then solving for other unknown variable. And it is called elimination method, because each stage of the process of solution, we eliminate one or more of the unknowns. That's why we are saying that it is an elimination method. And this method is always produce an exact solution. And this can be applied to the system of equation larger than just two equation with the two unknowns. So in this method, what we are doing, we are manipulating the equation in the system to eliminate one of the variable, allowing you to solve for other variable. So let us see here how by using the elimination method we can solve the linear equation with two unknown variable case. See, we want to solve one system of equation that is 4x plus 3y is equal to 11, and another equation is 2x plus y is equal to 5. Now let us see here the coefficient of x. In the equation number 1, the coefficient of x is equal to 4 and the coefficient of x in the second equation is equal to 2. And if these number had turned out exactly the same numbers, then what happened? We could have been eliminated the variable x by subtracting one equation from the another equation. But it is not necessary that we want to eliminate the variable x only. We can also eliminate the variable y as well. Anyway, for this purpose, we have to multiply one or both equation by appropriate number so that the sum of the coefficient in either of x or y is turned to be 0, so that we can easily eliminate it. So in this problem, see, we are going to rearrange this particular equation by multiplying the both side of the second equation by 2, so that the coefficient of the x may be equals. So if you go for multiplying the equation number 2 by 2, see, it will become 2 into 2x, which is equal to 4x, 2 into 2y, which is equal to 2y, is equal to 5 into 2, which is 10. So our second equation will become 2x plus 2y is equal to 10. Now we may subtract the equation number, this one, third one, from the equation number 1 so that we can eliminate the x variable. See, our equation number 1 is 4x plus 3y is equal to 11, and the equation number 3, which we are already calculated here, it is 4x plus 2y is equal to 10. Now I am going to subtract it so that the x variable can be eliminated here. So if you go for subtracting here, then 4x and 4x will be cancelled out. Then 3y minus 2y, which will be equal to y. So here 4x minus 4x plus 3y minus 2y, which is equal to 11 minus 10. So if you go for it, then 4x will be cancelled out. Then 3y minus 2y is equal to y, and 11 minus 10 is equal to 1. The value of y is equal to 1. And now we can substitute this number into the original equation, any of the original equation or one of the original equation, that is either in the equation number 1 or 2, so that we can find out the value of x as well. So here substituting y is equal to 1 on the equation number 1. So equation number 1 is equal to 4x plus 3y is equal to 11. So here we are substituting the value of y is equal to 1. So it will become 4x plus 3 into 1. Instead of y I am substituting 1, which is equal to 11. 4x plus 3 into 1, 3 is equal to 11. If I am subtracting the 3 from the both side of the equation, so it will become 4x is equal to 11 minus 3. So 4x is equal to 8 and x is equal to 8 divided by 4, or dividing the both side of the equation by 4, then it is 8 divided by 4 is equal to 2. So we have the value of x is equal to 2. Hence we have a solution here. The y is equal to 1 and x is equal to 2. So then in this way we can solve this particular equation by using the elimination method. Consider one more example so that it will be more clear. See, we have a system of equation 2x minus 2y is equal to 8 and x plus y is equal to 1. Now here we can multiply the equation number 2 into 2 so that either we can eliminate the x or we can eliminate the y. So if you multiply the equation number 2 into 2, the equation number second will become, see, 2x plus 2y is equal to 2. Now consider the equation number 1, that is 2x minus 2y is equal to 8, and equation number 3, which we are already calculated here, it is 2x plus 2y is equal to 2. Now we can go for add up so that y can be eliminated. If you go for adding the two equations, then y can be eliminated because the sign of here it is minus, here it is plus. So here I am going to add up. So 2x plus 2x plus minus 2 plus 2y is equal to 8 plus 2. So here 2x will become 4x then minus 2y plus 2y will be cancelled out, then 8 plus 2 which is equal to 10. So 4x is equal to 10. So x is equal to dividing the both side of the equation by 4, then it is 10 divided by 4 which is 2.5. So the value of x is calculated here, it is 2.5. Now after getting the value of x, we can substitute the value of x is equal to 2.5 in the equation number 1. So equation number 1 is equal to, it is 2x minus 2y is equal to 8. So substituting here x is equal to 2.5. So 2 into 2.5 minus 2y is equal to 8. 2 into 2.5 which is equal to 5 minus, taking the 8 into the left hand side of the equation. So it will become minus 8 which is equal to 2y. So if you go for solving for y, then it is 5 minus 8 is equal to minus 3 is equal to 2y. Then y is equal to, dividing both sides of the equation by 2, then it will become minus 3 divided by 2. So y is equal to minus 1.5. Y is equal to minus 1.5. So here x is equal to 2.5 and y is equal to minus 1.5. Now consider the another method for solving the system of linear equation with the two unknown variable case by using the direct substitution method. So how can we solve this equation by using the direct substitution method? See, we have the same example which we are already solved previously, that is solve the system of equation 2x minus 2y is equal to 8, x plus y is equal to 1. So while using direct substitution method, you can express one of the variable in terms of other variable and then substitute that expression in the other equation. So if one of the variable, generally in the term of in the coefficient having the 1 or minus 1, we will choose it, and then after that substitution method will be easier where we can solve it, because if you consider the coefficient 1 or minus 1, because the substitution method usually easy in this way. So the result should be equation with just one variable. See here, we can take the equation number 2 because the coefficient is 1. So the coefficient of both variable is 1. So equation 2 I am taking here. So considering the equation number 2, which is x plus y is equal to 1. So I am solving for x, then here 1 minus y. We can write this is 1 minus y because both sides of the equation I am subtracting with minus y. So it will become plus y and minus y will be cancelled out, then 1 minus y. So x is equal to 1 minus y. Then substitute this x is equal to 1 minus y in the first equation, another equation. That means here it is first equation. So in this case, see, if you go for substituting x is equal to 1 minus y, so our first equation is 2x minus 2y is equal to 8. Then 2 into, instead of x I am substituting 1 minus y minus 2y which is equal to 8. So I am opening the bracket by multiplying these terms. So 2 into 1 which is equal to 2. 2 into minus y which is minus 2y is equal to 8. So here minus 2y which will get minus 4y, then 8 minus 2, it will goes to the right hand side of the equation, so it will be minus 2. So minus 4y is equal to 6, y is equal to 6 divided by minus 4 which is minus 3 by 2 which is minus 1.5. So y is equal to minus 1.5. Now, what we want to do, here we want to substitute the value of y is equal to minus 1.5 in any one of the original equation, or you can also substitute here as well, x is equal to 1 minus y. So here substitute the value of y is equal to minus 1.5. Let us consider we are going to substitute here, that is x is equal to 1 minus y. So here substituting y is equal to minus 1.5. So 1 minus 1.5. So here minus will be plus. So 1 plus 1.5. So x is equal to 2.5. So this is very easy method, especially to solve the system of linear equation, that is by using direct substitution method. Now we can solve the one more question by using the direct substitution method so that it will be more clear. 3x plus 2y is equal to 1, and the second equation is minus 2x plus y is equal to 2. So here the coefficient of y is equal to 1, so it will be better to isolate the y, we have to convert this equation in terms of one variable. So here, taking the equation number 2, see minus 2x plus y is equal to 2. We are isolating for y, so it will become plus 2x will be added into the both side of the equation, so it will become minus 2x plus 2x will be cancelled out. So 2 plus 2x, y is equal to 2 plus 2x. Now we are going to substitute y is equal to 2 plus 2x in the equation number 1, because we are converted or transformed the equation number 2, so it is better to substitute equation number 1, sorry. So the equation number 1 is equal to 3x plus 2y is equal to 1. So here we are substituting y is equal to 2 plus 2x. So 3x plus 2 into, instead of y, it is 2 plus 2x, which is equal to 1. Now we are going to open the bracket by multiplying these two terms here. So it is 3x plus 2 into 2, which is plus 4, 2 into plus 2x, which is equal to plus 4x, which is equal to 1. Now 3x plus 4x, which will become 7x, and taking the plus 4 into the right hand side of the equation, it will become minus 4. So 3x plus 4x is equal to 7x is equal to minus 3. X is equal to minus 3, dividing the both side of the equation by 7. So it will become 7 divided by 7x, 7 will be cancelled out. So x is equal to minus 3 by 7. So when x is equal to minus 3 by 7, you can substitute x is equal to minus 3 by 7 on the equation number 1, or you can also put it here. Now we are substituting this x is equal to minus 3 by 7 on this particular term, that is y is equal to 2 plus 2x, where x is equal to minus 3 by 7. So it is equal to, if you go for simplifying it, 2 plus 2 into minus 3 by 7. If you here it is minus, so it will putting minus here. So 2 into 3, which is 6 by 7. Now if you solve it, then taking the common denominator, so here it is multiplying the 2 by 7 and dividing with the 7. So it will become 14 minus 6 divided by 7, which is 8 by 7. So the value of y is equal to 8 by 7, and the value of x is equal to minus 3 by 7. So this is the direct substitution method. Now, what happens if we have the fractional coefficient given equation? So we want to solving the system of linear equation with given the fractional coefficient. So if an equation that has a fractional coefficient, then the most common techniques used to solve the system of equation is, we want to clear the fraction by multiplying each equation by its least common denominator to clear the fraction. So for example, consider one equations here. See, 2 by 5x plus y is equal to 11 by 5. And another equation, it is x plus 7 by 3y is equal to 5. So here in the first equation, see the least common denominator, that is LCD. So we are going to multiply the both side of the equation by 5 so that we can eliminate the denominator or fractional coefficient. So if you go for multiplying with 5, so it is 5 into 2 by 5 x plus y, which is equal to, again, the right hand side of the equation also we are going to multiply with 5. So 5 into 11 by 5. So here the 5 and 5 will be cancelled out. So we will have 2 by 2x. We have a 2x, then 5 into y. So we have a 2x, then 5 into y, that is 5y, which is equal to, here the 5 and 5 will be cancelled out. So what is remaining here? It is 11. So we have denoting this is equation number 3. So now we have a equation without any fractional coefficient. So it is 2x plus 5y is equal to 11. The similar way, we also want to convert the equation number 2, because here also we have a fractional coefficient of 7 by 3. So in this case, we have to take the least common denominator, that is LCD. For the second equation, see here it is 3. So we can multiply the both side of the equation by 3. So we will get 3 into x plus 7 by 3y is equal to 3 into the 5. So here 3 into x, which is 3x, And this term 3 and 3 will be cancelled out. So what is remaining here? It is 7y. So it is 3x plus 7 by 3 into 5, which is equal to 15. So this is we are treating the equation number 4. So now consider the equation number 3 and 4. See, we have a system of linear equation. See, without having the fractional coefficient, we are already removed this fractional coefficient. So we have the system of linear equation, that is 2x plus 5y is equal to 11, 3x plus 7y is equal to 15. So now you can solve this equation either by using the direct substitution method or by elimination method. You go through it and solve it accordingly. Okay. Now we are going to consider how to solve the simultaneous equation with the two variable case by using the graphical method. See, the graphical solution involves plotting the equation on the Cartesian coordinate system. You know it is how we can plot the Cartesian system, which we are already discussed earlier. So then identify the point where the two graphs are intersecting. When the two graphs are intersecting, we have to identify that intersecting point. So the coordinate of this particular point represent, that is intersecting point represent the solution to the system of linear equation. So just see the stepwise procedure, that is how to draw the graph of a simultaneous equation. So the first step, we have to write down the equation in a standard form. That is, we want to convert the equation in the standard form, that is y is equal to mx plus b, where y is equal to y in the one side and the rest in the another side. So y here it is dependent variable and x is the independent variable. Now the second step, choose the values for one variable. That means choose several values for one variable, that is either for x or y, and calculate the corresponding values for the other variable using the equation. So this will give you, point that you can plot in the graph, that is coordinate points that you can plot in the Cartesian coordinate system. Then another third step, it is plot the points. So here we want to plot the points from chosen values on the graph paper and label the point with the values of their variables. Then after that, draw the line. By joining the various points on the graph, we will get a straight line. And after that, the step 5, identify the intersection point. See, the solution to the system of the linear equation is the point where the two lines are intersect. So this particular point represents the value of the variable that satisfy both equation. And last step, that is check the solution, that is substitute the value of variable from the point of intersection into both original equation so that you can ensure that both equations are satisfying or not. Now let us consider one example so that it will be more clear. See, x plus y is equal to 5, 2x minus y is equal to 4. See, as we already discussed how to solve the equation x plus y is equal to 5 and 2x minus y is equal to 4 simultaneously. And we could simply graph each line and find the point of intersection here. And since this point lies on the both lines, it coordinate gives the intersection point will gives the coordinate, and that will be the given solution. So we can write the first equation, that is x plus y is equal to 5. And we are converting this is in the form of y is equal to mx plus b or y is equal to ax plus b format. So isolating for y, we can write it is 5 minus x. Now I am substituting different value for x so that I will get a y value as well. Let us consider x is equal to 0. If x is equal to 0, then it is 5 minus 0, which is equal to 5. So our one of the coordinate point is 0. When x is equal to 0, y is equal to 5. When x is equal to 1, then it is 5 minus 1, which is equal to 4. So the coordinate points will be 1 and 4. If x is equal to 2, it is 5 minus 2. So the answer will be 3. So our coordinate points are 2 and 3. If x is equal to 3, then it is 2. So accordingly, the remaining points can be calculated accordingly. Now similarly, the second equation, that is 2x minus y is equal to 4. Again, we are isolating here, isolating y so that, we can calculate the different coordinate points. So we can write it is 2x minus 4 is equal to y. So y is equal to 2x minus 4. Similar to this particular version, we can also put here different values for x. For example, if x is equal to 0, then this particular equation we are substituting the value of x is equal to 0. So it is 2 into 0 minus 4, which is equal to minus 4. So the first coordinate point is equal to 0 minus 4. The second coordinate point, that is 1 minus 2, 2 0, 3 2, 4 4 and 5 and 6. So these are the various points which we can plot in the graph. So now assume the several values for the x and we have different values for y as well. Now we can go for drawing these particular points on a Cartesian coordinate system. See, in the first case, we are said that these are the various points. We are going to plot it on the Cartesian system. So this is the Cartesian space, and here we are going to plot the first point, that is 0, 5. So 0, 5 is here when x is equal to 0, y is equal to 5. So I am marking here. Similarly, 1 and 4 when x is equal to 1, so y is equal to 4. The third coordinate point, it is 2 and 3. So marking here, it is 2x and 3y. Similarly, 3 and 2. So this will be here. And 4, 1, which is, it is for the x value and 1 is the y value. And the last one, 5, 0, which is marking here. Now we have a different points. We are going to joining or interconnecting these points by using a straight line. And this is a downward sloping, or it is a sloping left to right, sloping downward from left to right. This is the graph of the y is equal to 5 minus x. So similarly, consider the second graph also. See, these are the various coordinate points. Now we are going to plot these points on the Cartesian space. So here 0 minus 4. So 0 minus 4 will be the point here. So I am marking here. When x is equal to 0, y is equal to minus 4. When x is equal to 1, y is equal to minus 2. When x is equal to 2, y is equal to 0. When x is equal to 3, y is equal to 2. Then x is equal to 4, y is equal to 4. Then x is equal to 5, y is equal to 6. So we have different points here. We are just going to interconnect these points so that we will get a straight line. And this is the graph of the equation y is equal to 2x minus 4. So once we have two different graphs, now we are going to joining these two graphs together. So we have the intersection point here. See, this is the intersection of the both graph. And at this intersection point, see, what is the value of x? The x value is equal to 3 and the y value is equal to 2. So at this intersection point, what is our coordinate points? 3 and 2. So here we can conclude that the answer to the solution of the system of linear equation with the two unknown variable through graphical method is that point of intersection. At this intersection point, we have x is equal to 3 and y is equal to 2. So in this way, we can find out the solution of linear equation by using graphical method. Now, what happens when the linear equations are parallel? That means that equation is not going to intersect. At that particular time, we doesn't have any particular solution. So when representing linear equation, graphically, if the lines are parallel, it means that they have same slope but the different y-intercept term. So in terms of this equation, this occur when the coefficient of x and y in one equation are proportional to the coefficient in the other equation, but the constants are different. So mathematically, these lines will never intersect. If it is parallel, these lines are never intersect, indicating that there are no value for x and y. And in this case, the system of equation is inconsistent and there is no solution. So when the lines are parallel, we doesn't have any solution to the system of linear equation. Similarly, if the lines are coinciding, then we have infinitely many solutions exist. See what happens if the lines are overlap, which means that these two lines are identical. So in this case, this occurs when the equation of the line are equivalent. If the equations of the lines are equivalent in terms of equation, this means that every point that satisfy one equation is also satisfy the another equation as well. So in graphical terms, the lines are right on the top of each other. Every point on the line is also in the other line. Therefore, there are infinitely many points of intersection will be exist. So in the case of, if the lines are overlapping, we have infinitely many points of intersection. So meaning that there are infinitely many solutions. If it is infinitely many points of intersection, then we have infinitely many solutions to the system of equation. So infinitely many solutions are there in the case of overlapping two lines. Now, see, we have a question, some practical questions we are going to solve. We have two numbers that have sum of 201 and the difference of 37. And we want to form two simultaneous equations in x and y format, and we want to find out what are the two numbers, so that this will give the sum of 201 and the difference of 37. So here let us denote, we have two numbers, that is x and y. And here the problem states that the sum of two number is 201 and the difference is 37. And we can set up two equations based upon this particular information. See, the sum of two number, that is, we can say that it is x plus y, because two numbers are x and y. So the sum of two number, which means x plus y is equal to 201, and the difference of two number, which means that it is x minus y. It is x minus y is 37. So we have the simultaneous equation with the two variable and two equation here. Two unknown variables are x and y. So we have two equations as well. So we have a system of two simultaneous equation here with the x and y variable. We can solve this particular equation. We can either use by using the elimination method or substitution method. For example, here we use the elimination method. So here, for that we want to add up. If you add up the both equation, then we can cancel out y term. See, so here I am adding here x plus y plus x minus y is equal to 20 plus 37. I am adding here both equation. So I am opening bracket, I am going to open the bracket here. So it will become x plus y plus x minus y, which is equal to 201 plus 37. So it is x plus x, it will become 2x, y minus y will be cancelled out. So here 2x is equal to 201 plus 37, which is equal to 238. And x is equal to, dividing the both side of the equation by 2, we will get 119. So now we have the value of x, we can substitute it back into the one of the original equation to find out the value of y. So I am considering the first equation here, that is x plus y is equal to 201. Substituting x is equal to 119 here, so it will become 119 plus y is equal to 201. Solving for y, we can say that 201 minus 119, which is equal to 82. So the two numbers here, it is 119 and 82. You can check these values whether it is satisfying the sum or difference or not. See, substitute x and y on here. So it will be x is equal to 119 plus 82. If you add up these two terms, we will get the 201. And if you substituting here also 119 minus 82, which is also give the same answer, that is 37. Therefore, we can say that solution here, the two numbers are 119 and 82. So x is equal to 119 and y is equal to 82. The two numbers are 119 and 82. Now consider another example. See, we have a theater ticket for 4 adults and 3 children, which having the cost of $74. And the theater ticket for 2 adults and 5 children is cost is $58. And we want to calculate what is the price of an adult ticket and child ticket. So here let us denote the cost of adult ticket is equal to A and the cost of child ticket is equal to C. Given information, from the given information, we can set up two equation based upon this particular information. See, from the first line, theater ticket for 4 adults, so 4A plus 3 children. So here it is 3C, which is equal to 74. So 4A plus 3C is equal to 74. Similarly, from the second information, that is 2 adults and 5 children. So 2A plus 5C is equal to 58. So I am writing here it is 2A plus 5C is equal to 58. Now see, we have a system of two equation with the two unknown variables, that is A and C, where A is denoting for the cost of adult ticket and C is denoting for the cost of child ticket. So now we can use the substitution method again here. See, first we are going to use the substitution method by considering the equation number 1. See, equation number 1 is equal to 4A plus 3C is equal to 74. I am going to isolate A here by taking 3C into the right hand side of the equation, so it will become minus 3C. So 4A is equal to 74 minus 3C. Then dividing the both side of the equation by 4, so 4 will be cancelled out. So A is equal to 74 minus 3C divided by 4. Now we can substitute the value of A in the equation number 2 or second equation. So substituting here, A is equal to 74 minus 3Z divided by 4 in the equation number 2, and we know the equation number 2 is equal to 2A plus 5C, which is equal to 58. So substituting here, A is equal to, see, 2 into A, that is 74 minus 3Z divided by 4 plus C, which is equal to 58. Multiplying with the 2 and dividing with the 4, then it will become 2 into 74 divided by 4, which is equal to 37. 2 into 3C, which is 6C, 6 divided by 4, which is equal to C, minus, plus we have 5C, which is equal to 58. We can divide 6 by 4, which is equal to 1.5C, plus 5C, which is equal to 58. If you go for simplifying it, then 3.5C is equal to 58 minus 37. C is equal to 21. 58 minus 37 is equal to 21. Divided both side of the equation by 3.5, we will get 25 divided by 3.5, which is equal to 6. So here the cost of children ticket is equal to 6. Now we are going to substitute C is equal to 6 in the original equation. Let us use the first equation here. Substituting back into the first equation, see, first equation is equal to 4A plus 3C is equal to 74. I am substituting here C is equal to 6. Then our equation will become 4A plus 3 into 6. Instead of C, I am substituting it is 6, which is equal to 74. So 4A plus 3 into 6, which is 18, is equal to 74. I am going to isolate for 4A, then 74 minus 18. Then dividing the both side of the equation by 4, so it will become A is equal to 74 minus 18, which is equal to 56 divided by 4, which is equal to 14. So the solution of the system of equation, that is A is equal to 14 and C is equal to 6. Therefore, we can conclude here the price of the adult ticket and the children ticket is 14 and 6 respectively. That is, the adult ticket is equal to $14 and the children ticket is equal to 6. So let me conclude here. In this lecture, we actually discussed the system of linear equation in which there are two equations and two unknown variables with two variable model. So I hope it was clear to you. In the next lecture, we will discuss the system of linear equation with three unknown variable case. So we will see in the next lecture. Thank you.